All right, we're going to start a new unit, Unit 9. It's about solving systems of linear equations, systems. Basically, what systems means is if you have a graph, normally what we've been doing is we've been dealing with a straight line on a graph. This unit, we will have two lines on the same graph. And our whole goal, the entire purpose of the unit, is to find that. That's called the point of intersection, okay, to where the two lines cross. I usually just call it the POI. The other word you're going to call this is the solution. That's the solution to the system, but that's our goal. We're going to go through an example that help this make a lot more sense, but that is basically our goal for today, how to find that, the point of intersection. So, I want to go through one example to kind of explain what point of intersection of two lines means. So here, I'm thinking of a starting number and a final number. I don't know what they are, so when I don't know what things are, let's call it X and Y. I'm going to give you two clues. Whenever you have these kind of questions, basically each clue is going to translate into an equation. So let's write an equation for each clue. The starting number tripled gives the final number. So the starting number we called X. Tripled means times 3, so 3x. Gives means equals. The final number we called y. So that is an equation right there. The second equation, if you add 6 to the starting number, so that means x plus 6, you also get, so that means equals, the final number y. So I have two equations right here. I'm actually going to write them the other way, just because it's easier to graph that way, or to visualize. Okay, I have two equations. Now the thing is, if I just looked at this first clue, okay, there would be infinite answers. So for example, the starting number tripled gives the final number. So if the starting number was 1, the final number could be 3. But it also, if the starting number was 2, the final answer would be 6, or 3 and 9. There's an infinite number of solutions. Same thing if I took just the second clue. If I took the first number 1 and I added 6, well, I would get 7. Or if I took 2 and then added 6, I would get 8. So as you can see, by looking at these clues separately, there's infinite number of possibilities. But what we can do is we know both of these clues are talking about the same thing. They're a system. They have the same starting and final number. This starting number is the same as this starting number. So by using that, we can use a graph to actually help visualize what's going on. So we wrote equations to help understand, and I'm just going to graph them. So y equals 3x, so I know that means plus 0. So the y-intercept is going to be at 0. And then the rise over 1 is 3 over 1. So up 3 over 1, up 3 over 1, up 3 over 1. And then I'm going to draw a line so I can see it. Drawing lines, this unit, is a lot more important because we need to see where the lines cross. We can't always rely on just those points that we use. Now this one, my intercept is at 6, and my slope is 1 over 1, so over 1 up 1, over 1 up 1, over 1 up 1, over 1 up 1, and we can draw a line. Now, this first section is pretty easy. When we look at the graph, we're trying to find where the two lines cross. That's obviously right there. That point, when we talk about points, we need to write them as an ordered pair, so an x and y value. So the x value would be 3, and the y value would be 9. So the answer, the solution to this question would be 3, 9. But this was also a word problem, right? So it was asking about starting and final number. So a starting number is going to be, like we said, x. So the first number in this question, x is 3. And then the final number, the y equals 9. So this was one example. Your textbook will have a lot more examples, but the basic idea of what you need to do. You get two equations, graph them. Wherever they cross each other, that is the answer. We will go through a lot more examples that make this a lot more complicated, but for now, that's all you need to know. The homework for today is these questions, so make sure you go through them, and that's it. Sorry, I realized I wanted to show how to do this on Desmos really quick. Let's take these equations we just said. So let's flip over. I wrote them down here. Okay. Once I graph the two equations on Desmos just by typing them in, it actually gives you a point that's grayed out that you can click on and gives you the coordinates. So So by doing that, you can actually see the answer really fast, and Desmos makes this really easy. That's it.